for you. So that's why I included doing all of it. But I think it only asked for the 3 or 4 things, actually. Okay, number 5. So number 5, vertical asymptote, set it equal to 0. Go a bit faster. We're going to minus 2 to the other side. So now we have 2x equals -2. Divide by 2, divide by 2. Woo! We get a -1 for the vertical asymptote. That's right here. Vertical asymptote. Horizontal. Horizontal. Powers are the same. So we use the what? Numbers in front. 4/2. And 4/2 is just a 2. Remember, the powers have to be the same. Either 2/2, x squared over x squared, or x first over x first. Okay, anything cancel from top and bottom? Not really. We don't see any holes yet. So no holes. So x-intercept, we set the top equal to 0. Y-intercept, oh, you did that really fast, Mr. Newell. Well, the top was 4x equal to 0. And we divide by 4. So the top equal to 0. And so x equals 0, y equals 0. But the y-intercept, woo! The y-intercept, we get 4x over 2x plus 2. And you do have to set the x equal to 0. Boom, boom. Oh my goodness, what's 0 times 4? 0. And 2 times 0 is 0. And 0 and 0 plus 2 is 2. But 0/2 is just 0. They're the same. 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0. Come on, brothers. So then we can go and graph our vertical asymptote at -1. Our horizontal asymptote at +2. Interesting. And we have x-intercept, y-intercept at 0, 0. So then our graph is going to come along this asymptote, through the x-y-intercept, along this asymptote. That means in the top left, it's going to also be there too. Now I highly recommend you use your graphic calculator, and you plug it in, you check. Ready? Make sure you use parentheses on the top and the bottom. So 4x divided by 2x plus 2. And let's see, we use parentheses, top and bottom. Let's see how we did. We did it right. Look at that. There's our x-intercept at 0, 0. And it curves out to the right, bottom right, and top left of our asymptotes. No holes, no holes. So all real numbers, remember, all real numbers, except, all real numbers, except x can equal what? X can equal -1. That's our vertical asymptote. That's our vertical. And then the side chart just goes from positive to negative. No, it doesn't, Newell. Ah, crap. Ah, crap. So it's on positive, and then after this vertical asymptote at -1, it goes to negative, and then after the x equals 0, it goes to positive. Positive, negative, positive. That's our sign chart. Positive, negative, positive. It changes at the vertical asymptote -1, and it changes at 0, which again is our x-intercept, and vertical asymptote. Okay, almost there, almost there. So now we're going to jump to number 6. These problems, I tried to make them really similar to the test. So if you can really understand these, maybe do it again on your own. Ooh, 6 is a good one, 6 is a good one. So to be able to do this one, what do we have to do to the top and bottom to get going? That's right, gotta factor it. I'll wait for you. Pause me. You should be pausing me and trying it on your own. What did you say, R2D2? I know, they need to try on their own. Just copy the videos and fail. Try on your own. Try on your own. So it factors into x squared factors of x and x. What are factors of 15? 3 and 5. Plus and plus. What are factors of 12? 3 and 4. Factors of 12 are 3 and 4. Uh-oh. Sine middle term has to go with a bigger number. Good, bigger number. Ooh, this time we do have a hole at discontinuity. We do have a hole. And that hole is where? It's the x plus 3's. So the thing that canceled is now called the hole. And so we take that x plus 3 and we set it equal to 0. We minus 3 to the other side. And so we have an x value of our whole at negative 3. How do you find the y value of the whole, the y value? Well, you take the simplified function which is left, which is the x plus 5. Remember? Do you remember? What do you do with that negative 3 for the x value? What do you do with it? That's right, you plug it in to get the y value. Plug it in, plug it in. 5 minus 3 is 2. 5 with a negative 3 is 2. Negative 3 with a negative 4 is what? Negative 7? Ooh, that's ugly. So we do get a y value, won't be that hard to test. We do get a y value of negative 2/7. Ooh. So negative 3 and down 2/7. Ooh. Right about there, I guess, is our whole. Ooh. Okay, what do we have left? Well, opposite sign, our vertical asymptote is at 4. 1, 2, 3, 4. Good. There's our vertical. What's our horizontal? Well, the powers are the same. So you could use this one and this one, or you could just use that one and that one, either way. 1 over 1 on the test is a 1. I remember that being quite a bit on the test, just like the practice, actually. So we have a horizontal at 1, and we have a vertical at 4. So then to find the x-intercept, what do we do again? Yes, we said y equal to 0 and x equal to 0. But for the x-intercept, you actually want to set the top equal to 0. Okay, I know, you're looking at it, you're like, Mr. Newbold, we're actually setting x equal to 0. Well, the thing with that, no, y equal to 0. Find the x-intercept, y equals 0. The thing is, if you make y equal to 0, and you want to solve for x, you've got to blend in x minus 4 in the bottom. And so you have to multiply it at the bottom over the other side. And when you do that, that's just, the bottom every time is just going to go away. Because x minus 4 times 0 is just 0. So you might as well just set the top. Might as well set the top equal to 0. And when you set the top equal to 0, you get a negative 5. So you get a negative 5, 0 for our x-intercept. To find the y-intercept, what do you do again? Remember? X equals 0. To find the y-intercept, and you get 5, negative 4? Yeah, you get 5 over negative 4. Because you set x equal to 0. So that's 0, negative 5 fourths, which is like negative 1.25, right about there. Ooh. Okay, now we can graph it along this asymptote, through the x-intercept, over the hole, through the woods, y-intercept, Granny's house we go, along the asymptote, and at the top right in the asymptote. Ooh, you want to do it day 2 style? Yeah, one of the problems on the test is going to be day 2 style. How do we do a day 2 style, Mr. Newbold? Well, day 2 style is going to be where we write the domain, and we use like parentheses and union with and stuff like that. Remember? So what you have to do is we're going to start off from left to right. We're going to go negative infinity until we get to our whole. And so we have a whole at x equals negative 3. And so the first part of it's going to be blue. And so negative infinity to negative 3 is going to be our domain, right? All the numbers between negative infinity and negative 3. And union with negative 3 to something, right? Because now we're going to go to red. And in red, we're going to go from negative 3 now all the way to our vertical asymptote where it stops again. And that's at 4. That's at x equals 4. So we're going to go ahead and go in union with negative 3 to 4, which is the x value of our whole to our vertical asymptote. Make that red, make that red. Last but not least, make it green. In union with, now we're going to go up here at 4. Now we're going to go up here at 4 where the asymptote is to infinity, right? Because our graph goes along with 4, and it goes from right forever to infinity. So now we're going to go 4 to infinity. And that's our domain. You could have said all real numbers except x can equal negative 3 and 4, or you can write it like that for day 2 domain. And then sign chart. Hey, this sign chart's not too bad. No, it is. What? Won't be that hard to test, promise? Maybe. So it'll be positive. Then we hit our x-intercept. So positive, and then negative, and then positive. So negative, positive, no, positive, negative, positive. Is our sign chart? And where does it change? It changes at our x-intercept, and our x-intercept is at -5. It also changes at 4, which is our vertical asymptote. There's our sign chart. Okay, last one. So last one's going to be number 7. And number 7, we're just going to use the calculator. Because number 7 is pretty tricky, because it has a slanted asymptote, not a horizontal. What you talking about? I'm talking about that the top power is greater than, use parentheses on the top and bottom. I'm talking about that the x squared, the top power, is greater than, x squared is greater than x to the first power. 3x squared is greater than 3x to the first power. So that means the top is greater than bottom. And when top is greater than bottom, what's our horizontal asymptote? Remember? Top is greater than bottom. Y equals horizontal. Y equals none. Or even better, it's actually slanted, actually. And so you can put slanted or none. Put slanted or none. Technically it is slanted. Good. Okay. Find the verticals, set equal to 0, add 3 to the other side, and then divide by 3, so we do get 1. We have a vertical at 1, good. Any holes? No holes. This is slanted asymptote. What the? X-intercept and y-intercept. So top equals 0, set the x value equal to 0. And so when you set x equal to 0 and y equal to 0, top equal to 0, you get 0, 0. And if you look at your graph and calculator, you'll see it. Graph, there it is, 0, 0, x-intercept and y-intercept. In fact, we're going to go over 2, up 4. That's where the other part of our graph is. Over 2, up 4, over 2, up 4. As well as 0, 0. Watch out, there's one of these on the test. Watch out, one of these on the test? It's called a slanted asymptote. That's so weird. So we have a slanted asymptote, which means it's like this. It's like a diagonal asymptote. That's crazy. Our domain, we're not going to do the range. And really not going to do sign chart either on that one, because that's just ridiculous. Because the Vicus is, no, I don't know. Let's ignore those two. I don't think they asked for it on the breakfast test. Domain is all real numbers, except for the vertical asymptote. So I guess you could say -infinity to the vertical at 1. And union with 1 to infinity, so that's probably true. Sign chart, negative and then positive. And it changes at the vertical and what? I think. Cool. Woo, that was a long video, but we had to get through 1 through 7 done. Because the next video is me at home. I'm doing it at home. Watch that video. You guys stream, thanks for watching, and not just playing it, but pausing it and trying it on your own first. Woo! Thanks for watching. Get to have Isaac now. Woo! Bye. Chewbacca, wave goodbye. Bye. Watch my next one.